So to go, let's start with the libraries that we need. So for this, we're going to need just one library. If I go over here to installed, we're just using this AI ESP32 Rotary Encoder library. And let me switch over to the browser here. Chrome. Okay. Oh wait, that's not what I wanted. I wanted the Chrome library. Where is it? Here, let me switch over to this. Oh. Okay, so this is the library out on GitHub. And the nice thing about all the libraries, that we have, they've got full documentation. So it's rather straightforward, and they do provide examples. So you can set a range that you want the encoder to transgress across. They also have a way to set up acceleration, so if you turn it really fast, it jumps in higher increments. Or you can disable acceleration so it only does one click per turn. It's got a built-in button. What we're going to play around with over here on VS Code is just the basic Rotary Encoder example that they have here. And so we're going to include this AI ESP32 Rotary Encoder .h. That's got all the definitions for it, and Arduino.h. And then we're going to define the pins. Like I said, we're using GPIO 5 for encoder A, and then GPIO 18 for encoder B, and then the button, we're using 19. And because we don't have this connected directly to its own power source, we're running it off of the SI5351. We define the VCC pin as -1. You could, if you wanted to run this off of another pin, you could actually take and say, I want to use pin 27, GPIO 27, and what it would do is it would force that high to provide the power for the encoder.
Hey, Jim, question.
Then we get, yeah, go ahead, Roger.
So I noticed your default is the 5351. Are you adding this to the 5351 project, or are you doing this as a separate project?
Oh no, let me switch my projects. I was working on code before.
Okay.
Thanks, because then I would be scratching my head. Why isn't it compiling? And we're getting that out.
Exactly.
Okay. Now you can also set the steps, and I've found that the 4 works the best. Let me minimize this a little bit. So matter of fact, let me just hide that. And then we're going to basically declare the encoder, and so we pass in the different pins and the VCC and then the number of steps. And then what they've done is they've created 2 buttons, or two like handlers. So we've got on button click, and what this is just going to do is to say, okay, the button was pressed X milliseconds after we restarted the program. And then we have a loop, and what this does is says if the encoder changed, let's read the encoder and print out the value. And if the button was clicked, then let's call the rotary on button click so that we execute this. And then we set up the interrupt service routine here so that you can actually, when you set that up, then it'll basically make sure that we get interrupted when there's things that happen. So then in the setup, We initialize the rotary encoder by calling begin, and then we set it up with the interrupt service routine. And then this circle's values, we're going to set boundaries. If that is set to true, when it reaches 1,000, it will go back to 0. So you could have this work like when you get all the way to the end, have it fall back to it. I've got it set to false, so it'll stop at 1,000 and won't go beyond that, or stop at a 0. And then this acceleration is set to 250. And so the faster you go, the faster it's going to increment numbers. And then all we're going to do in the loop is we're just going to call rotary loop so that it checks it and then delay 50 milliseconds and then come back into the loop. So let me go ahead and I will let me bring this up now. And I'm going to go, let's see, I need to plug in my 5351 first. All right.
Jim, how do you determine how much delay is you put in there? Is that just you just play with it, or is it
Well, so you got to think this is milliseconds. So if you're looking to read something and be actionable, then you want a very small delay or no delay at all. But sometimes it helps to put a delay in just so that things like the interrupt service routine can handle. If you're not worried about catching everything right away, then you can actually increase your delay. Let me bring up the terminal now. So now, as I turn the rotary encoder, you should see the values increment. And if I go really fast, you can see it jumps faster, but I can also just go onesie twosies. And I turn it to the right, then it's going down. So it's basically giving us back a value, and then based on how fast we clicked it, it basically increments the count out to us. So the library is actually maintaining the count for us and everything. So we don't have to do it. Now they also have a number encoder where you can have numbers and whatnot. Hold on. So we can, so you can actually, instead of dealing with this, you can actually set it to where the numbers and steps and that are different. If we go back over here to the libraries and ESP32 Rotary. Let me bring this back down and we're going to look. So he's basically using a. This is basically created a sample FM radio dial using the encoder, where he's actually multiplying the value by 10, so and then setting the acceleration to 50 so that you can actually get it to do like a half step faster or whatever. But they also, a couple of the other examples they have here is they do have like a number select, and this uses their number selector, the encoder number selector, and so what it does is you can basically set the steps and everything and just use the number selector once you attach it to the encoder. So like here they're setting a range to like 699 to 7,000 steps of 10, and then don't cycle the values when you get to the end, and then the number of decimals, and then he sets the start value so that you can get to it. So we could take this and we could we could run this and play with it. But I figured what we would do is I've set up a